Ryan, I made you the co-host. You should be able to present now.
Sounds good. All right, let's get started then. Can you guys see that just fine?
Yep.
All
Yeah.
right.
One second, I'm just
Good.
adjusting
Yeah.
Zoom stuff.
Okay, so we are Team Microsoft 2, and we chose the SIC XE assembler for our project. So the goal of this project was to create an assembler that takes in SIC files and outputs object code for specifically for XE machines. So our program is built entirely in C, and it's built on top of a pre-existing SIC assembler program from Project 1 and 2. It can generate object code from both SIC and SIC XE assembly code, and we use Github to make collaboration easier. So what's different from SIC XE from standard SIC? First of all, XE has some new registers. So the base register for base addressing, S and T are just additional like regular general purpose registers, and F is the floating point register. There's three new formats in XE. The first one, nothing is being referenced. There's no operand. The second one works on one or two registers, and 3 and 4 are two different ways to work with the extended memory size, since now SIC XE has 1 megabyte of RAM instead of just 32 kilobytes. And then M records are handled a little bit differently as well. Okay, I think, is this you, Nick?
Okay, so generally for SIC XE, the past one is still the same. It still populates the symbol table with the symbol and addresses, and it tokenizes each line as we go through. The majority of the work that we did was the changing of pass two. Generating H records and E records is generally the same. Most of the work we did had to do with P records and M records. We actually built a function that takes in whatever it's given. It takes in the instruction, it takes in where it is. It also tells us whether a base was hit or not. It also takes in the next instruction address as well and the address of the operand. That's for cases format 3 specifically where we have to do displacement. In that function that does all that, we also have the binary conversions like from hex to binary and binary back to hex. It also handles bit flipping in terms of if the displacement is negative, everything has to be obviously flipped from one value to the other and then add 1 for the conversion. And we also have the different addressing modes, format 1, format 2, format 3, and also the relative addressing in the other one. Error checking is also handled in the function as well. We check for if a instruction was in the symbol table or not. We also have if for format 2, if an invalid register is entered. There's a couple others. I'll mention them as we go. Next slide. Okay, so the formats that the function handles is format 1, obviously, is just an instruction. It'll print back the opcode. And that we have format 2, which can handle 2 registers being given to it, as well as if there's only 1 register reference format 2. Is normally done is format 1 is if there's just the instruction. Format 2 is if there's the 2 registers or 1 register. Format 3 is a big one. For the ones that have displacement, it handles those. There's a lot of checks in there for format 3. Format 3 is when they only begin with the plus symbol, direct addressing, and that's also when M records are generated as well.
All right, so with the program limitations, we have the maximum SIC XE memory size being 2 to the 20 bytes, the maximum symbol table size, 10 to the 24. Same with the T records and M records. And this is mainly due to the data structure limitation being arrays. We mostly came to the general consensus that linked lists would be way far out of the scope for this project that we're doing, especially since the source code that I provided was using arrays to begin with. And then last one here is it can take in both SIC and XE, but it will only output code for SIC XE machines. This was, again, a limitation by our design. So next slide. Difficulties, GitHub, I'm pretty sure we all struggled none of us had any GitHub experience at all, so we had to spend a certain amount of time all getting used to that. Getting familiar with the pre-existing code. Again, we used my pass 1 and pass 2. I tried to explain the code as best as I could, but there's always going to be that hurdle that you're going to have to jump over using other people's code. Understanding the changes from standard SIC. One example of this, obviously location counter movement was a lot more flexible with the XE. Hunting down unknown directives, the base and no base. These are 2 directives that we didn't even really find out about until they weren't in the documentation. And then obviously at the end here is the bug fixing that we had to get covered after we implemented all the logic. And then one other thing that's not on here is the just overall general complications when working in a group. There might be creative differences, or on the other hand, there might even be disagreements. So we had to get over that as well. So next slide.
To give you guys a little idea of how our program progressed along, we actually have a little example of an early instance of our code output. Here we can see we've got issues here in the beginning with our 2 T records overlapping a bit, and then we can also see over in the further down T records our object code. We've got those F's and the E. We had some issues with our object code generation function outputting only that, so that took us a little bit to iron out that issue in particular. And then we also had a couple other issues with string tokenization. I'm sure plenty of us have had experience with R sub and some of those other instructions and directives that are just only that middle token, having some issues with memory there. And then if we go ahead and move on to the next slide here, we actually have our most recent example of our program. So on the right here, we can see that our object code is much better, should be much closer to the accurate result expected. And we've got the byte T record up here generating properly, doing proper conversion. And of course, the end record actually also properly has proper output as well. In the previous one, it was incorrect. We can go ahead and move on to the next slide here. So while we do not have a man file built for our project, we went ahead in our GitHub repository and create and use the built-in wiki function to implement our documentation. And this can be used as a way of looking at what each function takes in as an input, what's expected as an output. In addition to, it'll also mention some specific error checking that's done on a per function basis. All right, go ahead and move on to the next slide. There are a couple things that we can certainly improve with our project. So as I mentioned before, we do not have a man page. However, we do have the GitHub documentation available. As stated earlier, this is all of our collective first time using GitHub. So we're still learning how to be more comfortable with it overall. But at least the basics weren't too terribly hard to learn. But we're still learning things like merging and Git blaming, other helpful functions like that within Git. Next thing we could improve, code cleanup and readability and optimization. If you were to take a stroll through our GitHub repository, you would find a lot of comments and printfs and commented out functions and stuff that are no longer being used. So it could definitely use a bit of cleanup overall, make things look a little bit more nice and concise. And after working on this project, and now we have a much better understanding of the SIC XE as a whole, we would be much more capable of building the whole thing from scratch again, instead of taking a pre-built foundation and building on top of that, which could also help with the above, where it would make our code a lot more cleaner with everyone having that new knowledge and understanding of the SIC XE. All right, good to move on. So that is our presentation about our SIC XE assembler. Thank you guys for sticking with us and watching. Does anyone have any questions today? Can you guys hear us?
We can hear you.
Yeah, I heard you.
Oh, okay.
Yeah, it was quiet for a second there.
All right, yeah, I guess that concludes our presentation then.
Okay. Thank you very much. Nice work.
Thank you.
Thank you very much.
Great job. Great presentation.
We appreciate it.
Okay, who else do we have? One other person wanted to present?